Alright, what's up guys? In this video we're going to pick up with some Calculus 1 basic integration. So this is just going to be example number 1, and in these Calculus 1 basic integration videos we will only touch on integrals that you learn in first semester calculus. So that'll include some very basic U substitution examples, but the vast majority of the integrals that we'll be dealing with for Calculus 1 will be basic and require no integration techniques at all. So this will be example number 1. Okay, so let's go ahead and integrate 4 times the square root of x minus 4 divided by the square root of x dx. So the first thing you need to do, if you're learning integration for the first time in Calculus 1, that's really when you get introduced into the concept of the antiderivative. The first thing that you need to do is to apply, in this particular case, we're going to apply the difference rule for integrals. So I'm going to rewrite the integral here as the integral 4 times the square root of x dx minus the integral 4 over the square root of x dx. So use your properties of integrals to break it up like this, and then deal with each of them individually. So the first, the 4 can come out because that's just a constant. And remember, if we take the 4 out, then that'll just leave me with the square root of x in our integrand here. So what's the antiderivative for the square root of x? Well, the antiderivative of the square root of x is just going to be 2 over 3 x raised to the 3 over 2. You can validate that by changing the square root of x. You could just change that to x raised to the positive 1/2, and then you apply the power rule, and you should arrive at that exact answer. Now we do have a constant 4 that's on the outside, so we're just going to multiply that by the antiderivative of the square root of x, which is 2 over 3 x raised to the 3 over 2. And so if we simplify, we'll get 8 over 3 x raised to the 3 over 2. So that's the antiderivative for the first part. Now we move to the second one. And again, we got 4 over the square root of x dx. So again, 4 is a constant. Take it out, and if you take it out, that just leaves us with 1 over the square root of x dx is what we need to integrate. Now again, remember that the square root of x can be written as x raised to the positive 1/2. So essentially you could think about this as being 1 over x raised to the 1/2, and if you wanted to move the x to the 1/2 up top, it would just change the sign of the exponent to a negative 1/2, and then you could apply the power rule. And that's what the vast majority of these integrals in first semester calculus, until you start learning about U substitution, a lot of these very basic integrals just require you using some algebra to basically rewrite a lot of these expressions. And if you notice, we're not doing any by parts, any trig substitution, or anything like that. We're just using some simple algebra to rewrite things. So this will become x raised to the negative 1/2, and then integrate it with respect to x using the power rule. Okay. So we got our 4, which is a constant, and we'll multiply by the antiderivative of x raised to the negative 1/2 dx. Well, that's just going to be 2x raised to the 1/2, or 2 times the square root of x, because the square root of x is equal to x to the 1/2. So this is just going to be 4 times 2x raised to the 1/2, because that's the antiderivative of that. And if we simplify it, we see what we get. If we simplify it, we'll simply get 8x raised to the positive 1/2. Okay. So now all we have to do is just take the antiderivatives that we got for both pieces when we used our properties of integrals, and we just have to write our final answer down by combining what we got, separating them using the appropriate operation, of course. So we got 4 times the square root of x minus 4 over the square root of x integrated with respect to x. So our answer to this integral would just be 8 over 3 x raised to the 3 over 2. And then we'll subtract that from 8x to the positive 1/2. And this is a very common mistake with Calc 1 students, is forgetting the constant of integration. But keep in mind that it's absolutely necessary. We have to have that for indefinite integrals. And so this is your answer. All right, so I hope that made sense. Again, that was just example number 1. I'm going to post another example as well. So I'll see you guys for the next example.